Okay, so hello everyone and welcome to our webinar on Introduction to DevOps Red Teaming. I'm Nandini Bharadwaj, the operating officer at CWL and your host for today's session. So it's fantastic to have you all here with us today. Let's get started. We are CW Labs, a global infosec company shaping the future of cybersecurity learning with a presence across UK, US and India. Our mission is simple: make cybersecurity practical and accessible. We do this through our two powerful divisions, that is, niche cyber range labs. It includes real world hands on cyber exercises. And number second is Infinity Learning Platform, a continuous learning hub built for modern cyber pros. Additionally, CWL provides customized on-site training for organization and accept bulk order for corporate upscaling. For inquiries or for more detail, feel free to reach out to us at support@cyberwarfare.live. Okay, so let's move on to the next slide. So our today's speaker is Abhijit Kumar. Abhijit is a security researcher with an expertise in red team operations, network security, cloud infrastructure, and Linux system. He is also passionate about researching adversarial tactics, techniques, and procedure, and frequently experiments in his home lab. So we are excited to hear his insights today. So that's all about the speaker. And dear participants, as promised, we are excited to share that you will receive your attendance certificate along with the video recording within 48 hours. And a lucky winner whose comment get the most like will get access of our latest launch, that is DevOps Red Team Analyst. So if you haven't participated or if you want to participate in the giveaway, I'll drop the link in the text box and you can just follow the step and participate. So thank you for being part of this webinar. We'll look forward for your continuous participation. And from here, without further ado, I would like Abhijit to take over and let's get started.
So before we begin this particular webinar, I just want to talk a few minutes about DevOps and why we need this DevOps red teaming. So this whole story of this DevOps, it begins with the software development. So software development is something where we create and deploy a software across our own infra or as well as the client's infra. And this follows a set of recurring phases, which include the analysis, design, development, test, release, deployment, or maintenance. And this is very essential whenever we are dealing with any of the software that is deployed at the enterprise level. Because if we do not follow these steps, we might have the delayed deployments, we might have lots of bugs, and we may even have something that is not even usable or something that cannot be considered as a software. So this DevOps or this software development, it occurs with a particular life cycle. And this is the software development life cycle, also known as SDLC, which begins with the planning phase, where the program owners and the other analysts, they plan about the particular software, they gather some details, they conduct meetings, brainstorms, and then once they have gathered the data, they move on to the analysis, where they plan about how to design the software, what will be the architecture, some of the components, and some of the other details. And then comes the designing, where the actual software is designed, high level architectures, low level architecture, system integrations, third party integrations, they occur. And then in the development phase, where the actual coding takes place. So before any lines of code is written, we have these three stages. And once the three stages are done, then only the coding begins, which begins in the development phase, also known as the fourth phase. Then once the software is developed, it is tested. And once it is tested and everything is done, it is then deployed and then maintained. Now, this is important because we can see there are several stages where as a red teamer we can attack these things. However, this is something very rudimentary, and we'll talk about these attacking in a bit later. So, this software development, if we have to automate it, so In that case, we need a set of practices or processes which can be streamlined across multiple organizations and which is equally distributed across the different environments or different infrastructure that the organization has. So here comes the DevOps. So DevOps is a software development methodology which streamlines the development cycle, and it combines the development and operations into a unified discipline. So before DevOps, what used to happen was there were the development team and the operations team. The development team, they write the code, they release the artifact, and they give it to the operation team for the deployment. However, here is a tricky part. There are two teams with very less communication. So let's take an example. Let's say the development team, they're writing their code in, let's say, C language, and let's say they're using something. Let's talk about the Linux. So they're developing their code on Linux and they're using the Ubuntu, let's say, server 25 or desktop 25 for writing the code. Now, when the operation team is deploying, they're, let's say, using the Ubuntu 18, 19, 20, or some other Linux system. So we can see different across different versions, software changes, libraries change, and these cause issues when we are deploying these softwares. And DevOps come came and solved these particular issues. So some of the DevOps tools and practices are the continuous integration, that is the CI, and continuous delivery, that is the CD. And this CI/CD is supported by the automation as well as the collaboration. Now here we are seeing a very detailed model of the DevOps cycle. So first we can see we still have the planning phase where we are gathering the requirements, we are planning the workflows, and we are generating tasks. Once that is done, we are developing the code using some sort of shared version control system such as the GitHub, GitLab, or Bitbucket. And once we have written the code, we are building it. And in terms of practical pipelines today, most of these builds they happen in cloud-based environments, and these environments are mostly offered by the services which are used to write the code. For example, if we talk about the GitHub, so GitHub also provides us with the GitHub Actions where we can build our code and push it. So once we have built the code, we are performing some sort of testing on it. These testings can be the unit testing, integration testing, security testing, system testing, acceptance testing, and the others. Then once the software is tested, dev part is done. This dev part is finished. Then the software is handed over to the operations team, where they release the software, they deploy it, and they operate and monitor it. So let's say if the software is released and there is a bug or some vulnerability, so then the operations team they will come back to the development team with the reports and they will ask them to fix it. And once that is done, the same cycle will begin again. Then planning, developing the patches, then again building the binaries or whatever artifacts, then testing it. Then again it will go through the same phase. So it is sort of an infinite going loop, sort of like an Ouroboros, which is a snake eating its own tail. Now, one of the important components of this DevOps is the CI, that is continuous integration, and CD, that is the continuous delivery. So this CI/CD, it is a DevOps framework which automates the integration of the code and the delivery of the released artifacts. Previously, if we go a couple slides back, in this particular stage, we can see a lot of things are there, lot of stages, at least 8 stages are there. And in a practical pipeline, there are even more stages. For example, this testing, it occurs here, then it occurs before the deployment, after the deployment, and like lots of other phases are there. However, this is a gist, and this particular CI/CD it automates these things because if we talk about the building of the code or testing and release deployment, all by the hand, that is the manual efforts, so it will be very tedious. and it won't be much feasible to do this if the organization is dealing with multiple softwares. For example, if it is a software development company, so they work with hundreds of clients. Each client has different requirements, different tools, different softwares that they require. So if they have manual setup, it will be very tedious. So they automate it using the CI/CD, and that is where the opportunities for us red teamers come. So this CI/CD, it is the automation of the manual practices, and it bridges the gap between the deployment and operations with the automation. So here we have a diagram which shows a typical high-level overview of a CI/CD pipeline. So first, we have the code. This code is for a software, and then once this code is started, right? Once the writing of the code is started, it is committed to a version control system. This version control system is a shared source code repository where multiple developers or multiple teams they push their code and they perform certain operations. Now, this is our first point of entry because if we can gain access here, we can modify multiple things. First of all, we can modify the source code itself so that whatever binary we are using, it is compromised, it is already backdoored. And we have seen these things in supply chain compromises. And if you remember a couple years back, there was a very massive supply chain breach at one of the big companies, and the attackers, the APT group, they managed to backdoor one of the software binaries, which was deployed across multiple Fortune 500 companies as well as the government agencies. So, similarly, if we get access at this level, we can perform similar supply chain compromises. Additionally, we may not need to backdoor the binaries, but we can also pivot into the CI/CD pipelines. So this is the example of a CI/CD pipeline. So let's say we land here at this commit stage, this source code repository. Then we can compromise the build stages. We can exfiltrate the secrets, perform different operations, and we'll look into these attacker actions in a bit later. So once the development team they push the code to this shared source code repository, certain operations start. This is the CI, that is the continuous integration. So here, this particular software, this particular source code, it is built and certain tests are performed. These tests could be the unit test, integration test, again, security testing, system testing, and the other testing. After that, this CI part is done once the tests are conducted and an artifact is produced. Then comes the CD phase, that is the deployment. Now, for the deployment, some of the source code review might take place, then the artifact is being pushed to the staging environment where it is again tested and certain security testing and other checks are performed. And once everything is cleared out, it is moved to the production. So this is the gist of a typical CI/CD pipeline. And some of the platforms which supply these CI/CD services are the AWS Code Pipeline, Azure DevOps, GCP DevOps, Jenkins, Circle CI, and Travis CI. Now, as a red teamer, we have seen the pipeline, that is this one. Now we want to see some of the components which we can actually target. So the very first component is the version control systems. And these are typically the entry point for any of the CI/CD stages because these are where the developers they are collaborating, and this is where the execution of the pipeline starts. So typically, once the code is pushed to the source code repository, version control system, certain stages or certain checks are there, and these checks first validate the code and then they trigger some CI/CD pipelines. So this is our entry point in most of the scenarios. After this entry point, we have the build tools. They can be compilers and some of the other tools. Then once this build stage is done, we have the artifacts. These artifacts can be either the executable files such as the exe, dll, elf, maco, or they can be some of the other non-binary formats such as the docker images. And these artifacts, they are stored in either the artifact storage or the cloud storage, and these are mostly the locations from where they are deployed. So taking the example of the docker, so when we build docker images, we typically push them to a docker hub account. This docker hub account contains the repositories where these images are pushed. So if we gain access here, we can compromise these images and we can change them, backdoor them, and whoever is pulling these images, they are again compromised, and we can execute whatever we want on their machines. And if you have been watching latest news, so you might have heard there were several crypto compromises, and one of them included a malicious docker image that a developer downloaded, pulled, really, and they were compromised. So this is how these sort of things happen. Then the deployment tools. So these tools mostly include the virtual machines and containers, and these are most commonly used deployment methods. So these virtual machines, they can be either the on-premises, that is the client's infra, that is the servers or data centers they host locally, or they can be in the cloud with the providers such as AWS, Azure, GCP, IBM Cloud, or Oracle Cloud, or any others. Then the containers. Again, these containers can be in the format of the local on-premises servers, and they can be in the cloud. Talking a bit about the containers, so when we are dealing with the containers, we usually have lots of containers that run at the same time. And at an enterprise environment, the list of containers, the number of running containers at a given point exceeds like thousands of containers. So if we are running containers at this scale, we need some sort of tools to manage it. And this is where the container orchestration comes into the play. So these container orchestration platforms, they include the Kubernetes, which is by far one of the most popular orchestration platform out there. Then some other platforms like Docker Swarm. Now, these containers or these Kubernetes deployments, they usually run in sort of an isolated environment. That is, they are segregated from the other containers and the host system. However, if we talk about the default configurations, so most of the deployment tools, they allow these containers to run as privileged. And when the containers are running as privileged, so they have certain higher level of activities or access within the host kernel. So if we gain access to any of these containers, which is running with the privileged access, we can actually pivot into the host platform. And once we pivot into the host platform, we can perform a myriad of activities. Like we can compromise the host, we can accelerate everything, we can spin up malicious containers, we can even stop the containers, we can inject into the processes, we can inject into the host's kernel, and lots of other things. We can also pivot into the other machines or other networks. So moving on. So when I actually began some research a while back, I was asking myself a question. Ki, there are lots of stuff out there that focuses on the DevOps and specifically DevSecOps, but very few resources they actually talk about hacking DevOps or DevOps red teaming. And there are obviously some exceptions, like some of the threat intel reports about the APT groups, which compromise the CI/CD pipelines. We have some interesting talks by security researchers at conferences like Black Hat and DEF CON, and we also have some independent blogs which talk about these things. And one of the most commonly talked about vulnerabilities or misconfiguration is hosting the runners which execute the code in the privileged mode, and we'll talk about this in a bit more detail later on. So moving on, We have a DevOps threat matrix here, and we can see some of the red team chains or red team phases here. So the first step in the kill chain is the initial access, which is the SCM authentication, that is the source code management tool or the version control system. Then we have the CI/CD service authentication, which means direct access to the service or platform which is executing the CI/CD. Then the configured webhooks, public repositories, and endpoint compromises. So we can perform multiple operations across these things, and it is very easy if we talk about compromising these things, because a lot of these misconfigurations they occur because the settings are left as default. And when we talk about default, so default is never ever good. So once we get the initial access, we can execute certain things. So first is the poison pipeline execution. That means ki there is a CI/CD pipeline, for example this one, and we have access here. Then we can compromise everything from here. We can inject something in the build stage, which will in turn inject a backdoor into the binary or the source code or whatever artifact is being built. So once we inject something into the artifact, so wherever it is running in the testing or the staging or production, it is backdoored and it is doing something that we want, something that is not intended. Then we have the dependency tamperings. So lots of softwares and even like every programming language, they allow us to write some code. However, most of the time we do not write everything from scratch. So we import some libraries. For example, if we take the example of the C language, so if we want to perform the printf or scanf, something like that, so we include something like stdio or conio for more integrations. And these things are libraries that are already written by someone else. If we take the example of Python, so in the Python, when we are writing something, we are importing something like import OS or import Flask or anything. So these are other libraries which are written by someone else. And in case of Python, so most of these libraries or these packages, they are hosted somewhere else. In most cases, hosted on the PyPy, that is Python Packaging Index. And it is very easy to publish packages. We just have to write our code, make it into a class, and publish it. And here comes the tricky part. If we can find something, some library, and talking about a real scenario, so let's say there is a software which is importing some dependencies, and let's say one of the dependency is internal, so that dependency is not exposed to the outside public, it is just internal system, and it is just importing these locally and just running it. Now, if we can find a public version of that particular package, so let's say we are auditing that software is okay, there is one dependency that is, let's say, example package, and we search something like PyPy and we see there is no package like that. So we can actually upload a package there, and in most cases, these softwares or these package managers which we use, they will actually revert back to the publicly available packages, because that is how they're actually configured. And if you remember, so some time back, there was a fork of SemGrip was created. It was named OpenGrip, and it had a PyPy link for downloading the OpenGrip. Now, one of the researchers, they actually found that the package that this installation link is referring to, it does not, it is not hosted publicly. So it is just some sort of a different link, and they created a package, they published it, and they compromised that particular package. And in the result, they got callbacks from big companies, and it was something that was very, that could have been very catastrophic if they had the malicious intents, because they could have compromised the pipelines of these companies, exfiltrated the secrets, created backdoors. It would have been a very massive supply chain attack. And not naming shaming, but just an example. So the similar things have happened in the past as well, and they might also happen in the future. So this was the dependency tampering. Then the DevOps resource compromises and control of common registry. So this resource compromise is something that is, let's say, again taking the example of this one. Let's say someone is building here at this particular machine, this build stage. Now this build stage will need a virtual machine or container to execute the stages, compile the code and push it. If we can compromise the machine itself. So for example, if for the machine, this build stage, it is running in an on-premise machine, on-premise VM, and this VM is, let's say, non-ephemeral. So this VM, let's say, it was created 1 year back and it is still running. So in that case, if we get access to this particular VM one time, we can actually have persistent access and we can compromise all of the future builds until this particular VM is terminated and a new one is started. And again, if we have still have the access here, we can again compromise that one and have the access later on. And control of the common registry, it is the same thing. So if we can find something that is available in the that is not available in the public internet but only available in the internal network, we can compromise the registry, we can create a similar package and just get the execution. Then the persistence, so that is the changing code or pipeline configuration. So for example, we can backdoor the code or we can change the pipeline configuration such that we can create a webhook which will be giving us some information every time a pipeline is executed or something similar. And then we can inject in the artifact, we can modify images in the registry, and we can create the service credentials. So these service credentials will be done in the case of the clouds or the Kubernetes, where we can create the service account tokens in case of Kubernetes, or we can generate the cloud credentials in terms of the cloud providers. And then we can escalate the privileges by exfiltrating the secrets, and we can commit from the pipeline to the protected branches. And these protected branches are some of the branches where no one can push, and they might have some privileged secrets or some configurations. And we'll see one of the similar demos. Then again, we can exfiltrate some certificates and identities with the metadata services, and mostly they happen in case of the cloud providers. So these cloud providers, they host a common IMDS, that is the instance metadata service, which generate the credentials for the machines or for the services that request, and these credentials are usually temporary. That said, even though they are temporary, they still have a decent level of accesses in default scenarios and very beneficial for escalating the privileges and moving laterally. Then they can get the direct credential access, that is the user credentials or the service credentials. Then lateral movement with the compromise of the build artifacts, registry injections, and they can pivot from the pipeline to the deployment. So for example, let's say they committed the code here and they injected some code here in the artifact, and once that artifact is published here in the production, so they will have access over this production machine. From there they can pivot to the other environments or perform certain other operations such as the persistence or creating resources. Then the defensive version, like they can manipulate the logs, they can do some compiler flags, and they can change the settings, they can reconfigure the branch protections. That said, these are usually not visible until or unless there is a very decent level of privileges, because these logs, they're usually shipped to the CM or XDR tools. And again, this compilation manipulation, so for this they might need to modify the pipeline itself, the services which are managing the pipeline. From there they have to change the settings, include different flags. And this branch protection, they can again only do this if they have admin level privileges over the particular repository. And the impact is the DDoS, crypto mining, local DOS, resource deletion, creation. And again, this is the most beneficial thing from a threat actor's perspective or even as a red teamer's perspective, because once we start a red team engagement, we are given some sort of task that is our end objective. And this task usually involve most of the times to exfiltrate some secrets from one machine or from one system or from one department. So moving on, we have some CICD security risk, and these begin with the first one, that is the insufficient flow control mechanism. So this means when we are configuring our deployments, our pipelines, so there is a pipeline flow. So we can see the flow here, that the code is committed, then CI is started. Once CI is finished, the CD is started. And if we cannot protect these integrations, these jumps, so first commit code is committed, then the stage jumps to the CI. Then once CI is finished, it jumps to the CD. So again, if we cannot control the or monitor these jumps, so it is very drastic, because anyone can commit something. They can jump here, from here they can jump here, and they can inject the codes or inject the commands. And in most cases, it will be RC or arbitrary command executions. Then we have the inadequate identity and access management, which in most cases is running pipelines as admin, running several services as admin, or even generating the paths for the source code tools with the admin privileges. Then the dependency chain abuse, which we already saw. The same thing, this dependency tampering, poison pipeline execution, and this insufficient payback. So these again refer to the scenario where we are compromising these stages. So the first one, that is the PPE, poison pipeline execution. It means that once we get access here, we are executing any code here, any arbitrary command here. So most of the CI platforms, they actually offer to restrict the execution of the shell commands or the other commands and harden the pipelines. However, in most of the cases, these settings are not turned on by default. So that will be the first one. Then again, insufficient payback. So that would mean that once the code is executed here, in let's say this one, so the access control is not properly monitored. So let's say this service, this build, it is running with the admin privileges. So from there, they can actually pivot into the other services, because once they exfiltrate the token for this particular service, they get admin privileges. Or let's say there in this production, let's say they are using Kubernetes. And in the Kubernetes, we have the concept of the role-based access controls, and we usually have a service account, which is having, and this service account in most cases will be running as something as cluster admin or something, which has the admin privilege over the entire cluster. And if they can exfiltrate those things, so they can actually move way beyond, they can create new clusters or disrupt everything or inject the code in any of the pods or any of the deployments. Then again, the insufficient credential hygiene and system configuration, these things are pretty much the common things that we usually saw. Again, ungoverned uses of the third party services. It will again come to this dependency tampering and control of common registry. Because if we talk about the scenarios, so a lot of shadow resource is used by the employee. So these shadow resources, they are something that is not actually monitored by the SOC teams. So for example, let's say if someone is writing code, and let's say they're writing code in Python, and let's say they have to use Flask for the deployment, and Flask is mandatory by their SOC team ki you have to use this particular version, or this particular library only. However, let's say they want some other features. So they might look for something that is Flask v2 or Flask new revision or something like that. So once they start using those resources, they come under the category of the shadow resources because they are not approved, neither they are monitored. Then the improper artifact integrity validation. So again, if we go here, so once this particular thing is happening, this commit happens, and an artifact is being built here. At this same point, there should be a checksum that should be generated with the artifact, and it should be matched at each of the levels. So if we go here actually, and we see this one, this modify images in registry. So let's say someone manages to gain access to one of the Docker registries, Docker repositories by one organization. And let's say the organization pushed image name as example Docker image, tag is let's say latest. Now the threat actor or the red team, they saw that new image is being pushed and they have the credentials to the registry. So what they do is they create their own malicious image with the similar configurations. They just add a backdoor, and once they add a backdoor, they push it to the same repository with the same name, that is the example Docker image, tag is latest. Now once anyone is pulling these images with the same tag, that is Docker pull example Docker image tag latest, so they will be pulling the image from the attacker because they are using the tag not matching the checksum. Then the last one is the insufficient logging and visibility, and it is pretty evident like what this means. So once we are talking about the pipeline, we still need to monitor everything, and ideally it should be monitored from the source code stage till the deployment, that is the final deployment in the production. However, some of the blanks might happen. For example, if someone's someone is integrating the Docker Hub or some other artifact repositories that are the third party, so it might not be feasible to get the logs, and that is where the issues come. So we can also abuse this because most of these pipelines, they're not monitored thoroughly. Some of the stages might be monitored, that is let's say the production is being monitored heavily, but the build stage is left unmonitored. So we can actually abuse that and gain access to the other services. Now, talking about the DevOps Red Team Analyst, so we actually developed this course which focuses on the offensive operations across the cloud native and on-premises CI/CD platforms. And we have designed it across multiple CI/CD pipelines with very realistic attack scenarios. The attack scenarios which had happened previously and conducted by the threat actors and the red teamers. And we cover some of the topics that include the DevOps and DevSecOps fundamentals, which include the different phases that comprise them, some of the services and tools that are used during different stages, and what we as the red team operators or the pentesters can do with these services once we get access to the version control system, that is the source code repository or the initial point of access for these DevOps or CI/CD pipelines. And this course will focus on exploiting the default configurations and common misconfigurations that occur during the DevOps lifecycle. This is the course flow for the DORTA, that is the DevOps Red Team Analyst. And first, you have to enroll in our on-demand course, then complete our study materials, which include the 500 pages plus PDF and 8 hours plus of HD video. Then you have to schedule the lab access, which will be the 30-day lab access, which will comprise across multiple cloud-based platforms as well as the on-premises platforms. And then you have to take a 24 hours exam, where the first 12 hours will be the hands-on exam, and you have to share the report in the next 12 hours. And if you clear this with the 70% criteria, you will earn the accreditable badge. This is the lab architecture for the DORTA. And you can see in the cloud, we are targeting three of the platforms, that is AWS Code Pipeline, Azure DevOps, and GCP DevOps. Then in the on-premises, we are targeting the Jenkins, and also we are targeting the Terraform. So with this, I'm just gonna go for the demos, and I'll just check if we have any questions. So no questions yet. So I'm just gonna go for the demo real quick. So here we have one repository here, and in the repository you can see we have some Docker files and some of the other files. Actually, let me open it in the VS Code. It will be more easy there. So you can see we have a Docker file which is building some artifact and running some of the one web application. And in the this particular directory, that is .github workflows, you can see that we have two files, Docker image YAML.bat and tokenxfil.bat. So as I talked previously, This GitHub allows the users to execute the builds, and these builds happen in the runners, that is the GitHub runners. These runners can be either the on-premises, that means the clients they can actually execute these runners in their own infra, own data centers, and they can be hosted by the GitHub. The GitHub one, they're the ephemeral, whereas if we talk about the on-premises self-hosted runners, in most cases they are not ephemeral. That means they are just the virtual machines which runs continuously. Now, this GitHub runners. So here we have configured a runner, and this runner is, in case of GitHub, it is known as this GitHub CI/CD. It is known as GitHub Actions, and it allows us to run the code in the runners. Okay, and these runners we can configure some of the variables, these secrets, and these secrets can be for the credentials. So you can see we have the Docker path, Docker repository, Docker username, and this DevOps demo secret. Now, if we click on this update button, we can see we cannot actually see the value here. That means once any of the maintainers they configure this, after that they cannot see the values. They can only change it, and this is for the secrets. Now, I'll just explain something. So here we have one Docker CI, that is the Docker continuous integration, and here we can see we have some of these stages. And what this will do is, on push or pull request to the main branch, it will start a job on this particular Ubuntu latest that is hosted by the GitHub. We have one actions checkout, which will be copying the entire files present in this particular repository and running this command, that is building a Docker image out of it. You can see Docker build, and it is giving the file name, that is the Docker file, with some tags. And after building this, it is pushing it to one of the Docker repositories using these credentials, and this secret Docker username and secret Docker path. And after authentication, it is pushing it and it is logging out. However, these credentials they are stored here. They are mapped in this particular GitHub Actions. So we can write our own action, and you can see we have written our own action, that is the data exfil, which will be executed on the same conditions, that is push or pull request to the main branch. It is again running on the Ubuntu latest in the same environment, that is this is being run at. However, the environment doesn't matter as long as we can run this particular action and execute our commands. Now, we have set one particular action job here, that is this particular one. So what we are doing is we are mapping this particular variable, that is the secret variable, as an environment variable named hidden, and then we are exfiltrating the value of this particular hidden, which in turn will exfiltrate the value stored in this one, this DevOps demo secret, which we can see here again. If we click here, we can see we do not have any means to observe the value. However, once we do this, so we have already run this command, already input this command, and I'll explain what this is doing. So we are using curl to query to this particular URL, which is a webhook URL, with this content type application JSON, and with this data. Data means the post request. So we are sending the post request to this particular URL using curl with the value of the hidden. This hidden in turns contains the value of this particular secret. So let's save this, and I'll quickly go here. So we can see the code is being pushed, and if we go here at the repository, we can see a job, a runner is started, and if we click here, we can see some of the initialization and the other stages have started, and setup secret is already done, and we can see a job is completed. Everything is green here, and if we go here, to this particular webhook URL, we can see we received a content that is the hello world. Now, what happens if we modify it? So let's actually try to modify it. So let's name it introduction DevOps. Now we are updating the value to this introduction to DevOps Red Teaming, and we have updated the value here. Let's delete this and let's go back here. Again, we are pushing it, and I just added this file so that we have a new commit, and we'll go here. We can see this ABC is here, and this runner is again getting executed, and we have some errors, and not sure what the error is, but we can see, okay, so I think I know why this happened. So let's actually go here one more time. So this happened because it was not segregated with the underscores. So let's try this one more time, and I really hope that demo gods they support me this time. Also, notice this particular IP. So this is the IP that is the 20, 246, 78, 242. We got this, and you can see the IP is different because this is the ephemeral IP, and this machine is getting terminated after each of the build. And in the second one, we can see we actually got the whole secret that is contained here. So let's go back to the slides. So with this particular webinar, my marketing team just reminded me that we are running a particular giveaway on this particular DORTA course. So I'll drop the link in the chat, and then I'll be looking into the questions. So I'm just dropping the link in the chat, and this DORTA. So actually, I'll also drop the link as well. Yeah. So I have dropped the link for the giveaway as well as the course. So you can take a look, and now I'll be looking into the questions. Those who know the code writing can take DevOps Red Team, or no knowledge of code can also take. So technically, to take this DORTA, so it is a very beginner friendly course, and if you know the code writing, you can take it. That said, if you come across some of the terms, you have to look these up yourself, because even though we actually designed it for the beginners to the DevOps red teaming side, it still contains some of the things like let's say reverse shells, or some of the setups, or some of the cloud knowledge. So if you come across these, you have to look those up either yourself, or you can take some other supplementary courses, or do a research on the site. But it is still very beginner friendly, and if you understand the basic concepts, you would be very good to go. And like if you take the DORTA, so it is a lifetime access, so you can go over the study materials at your own pace, you can take your time, and once you have understood the concepts, you can go for the lab and the exam and everything. Is proctored exam? No, exam is not proctored, so we do not proctor people, it's open book exam. So we will give you some access to the lab infra. This lab infra will be for the practice lab, where you can practice the scenarios, and the exam lab. So exam lab will be the 12 hours. You will have 12-hour access to this exam environment, and you can use any of the tools you want. You can use the AI like ChatGPT or others, or you can use some books, some other resources, and whatever you want. So we do not proctor. That said, you at the end of the exam you have to submit a good report. So yeah, and I cannot reveal more about the exam environment, but yeah, so this is the usual flow. Any free coupon. So I think the marketing team is running a giveaway. So I have just shared the link in the chat. So if I'm also pinning this, so I have pinned these two messages. So if you go the first one, that is the LinkedIn link. So you will see the giveaway there, and I'm sure they're giving some free courses. At what point in life should I focus on this, considering that I'm currently working exploit development using Python and C? And also, what does the job market looks like for this field, and when will I actually need these skills in path of becoming red team operator? So, I have to ask what exact job role you are working right now? Like, because you have mentioned that you are doing the exploit development and like the others, but can you let me know what job role you have right now? Like, is it pen testing or some other role? Because once I get that, I can give you a very good answer. Okay, I haven't received any answer, so I'll tell you. So you can take it at any point. However, if you're working on exploit development right now, you can focus on that. You can also do this simultaneously. It depends upon person to person. And when you are doing the red team operations, that is the proper red teaming. So you will need the different skills, at least at the understanding level. So when we talk about the red team, so it's a team, not a single person, right? And every operator is having certain skills. Like for example, someone might be very good with the maldev, someone could be very good with the initial access, someone could be very good with the post exploitation activities such as the lateral movement, persistence, pivoting, and the others. So given what you have told me, you will need it once you actually start with any projects which involve anything remotely to the source code development or source code audits or these supply chain audits. So these are the most common fields where this knowledge will be used. Also, if you deal with the cloud, so we have also covered a lot of cloud offensive operations in context of the CICD, but still they are applied to the general stuff as well. So yeah, Coupon Gabriel, I have penned a message in the chat. So if you could please check the chat, there is one LinkedIn link. And if you go to the LinkedIn link, you will see our marketing team has um, posted some of the activities which you can do to get access to a free coupon. I'm not a penetration tester yet, but I'm currently looking for a job while working as a teacher. I teach basic networking, provide an introduction to, yeah. So, um, okay, so you are teaching basic networking and introduction. Okay, so like you can take it right now as well, because if you are talking about the introduction to various fields, so this is also an introductory course, although it is not very beginner friendly. Like this is not for complete beginners. However, if you understand some of the basic things as we have mentioned, so you can take it right now. And as I mentioned, the access is lifetime, so you can have access to the study materials for the entire life, and you can go at your own very own pace. So yeah, so I hope that does answer your question. If not, you can either reach out to me on LinkedIn or you can mail us. And yeah, it is which type of activities? I do not understand. Can you please elaborate? Like, what activities do you exactly mean? And if you're asking about the activities of this particular webinar or this particular DevOps Red Team Analyst course, so it is focusing on the offensive operations across the DevOps pipelines. These pipelines are spread over the cloud, which covers the AWS, Azure, and GCP. and the on-premises where it covers the Jenkins and Terraform. Okay, what type of activities? Okay. I have already posted the link in the chat. I'll just open it. So, I think you can find this detail here. So our team, they edited and they added some of the activities you have to do. So please refer to that particular link. Okay, I'll just share my LinkedIn. Just give me 1 second. So I'll just share one of the posts. So I do not like see. So this is actually my username, Abhijit SecOps. But I think if you open this particular post, so you will find it. So let me just open it. So yeah, so this is my profile, and let's say if I can copy it here. Yeah, yes, so I have pinned it as well. I cannot see that. I just shared in the chat. So you can see it is Abhijit tag SecOps. Okay, so if we do not have any other questions, so we will conclude this webinar. If anyone has any questions, please raise your hand. Otherwise, we will be ending the webinar. Okay, doesn't look like anyone has any further questions. So thanks, folks. Thanks for joining, and we will see you next time in some other webinar or some other. It is like internal red team, right? Or external pen test. So if again, I'm not sure, Shiva, what you mean by the internal red team or the external pen test, but this DORTA, it is sort of external to internal operation because we start from the external, that is the source code repository, and then we end with the internal, that is the final production deployment. So that is the flow for this DORTA. And with this, let's bring this webinar to a close. So again, thanks folks, thanks for joining, and yeah.